All right, by now you should be done with your circles or squares and triangle project, and now we're moving on as to why we went through and learned that. And so at the top of your notes, make sure it says this, Chapter 4, Section 8, Pythagorean Theorem. Alrighty? So here we go. Learning target for today is that I can find the length of a missing side of a right triangle using the Pythagorean theorem. Okay, pause it. This is kind of a long one today if you need to get that all recorded. So stop the video so you can do that. Okay, now, first of all, the word theorem. We use that a lot in later on mathematics and upper level stuff, and so especially in geometry. And so what does it mean? Well, basically, it's a fancy word that means it's some kind of rule or some kind of proven statement in math. And so we use the word theorem to say, yep, this is kind of a law, a rule, something like that that's been proven, and so we can accept it as truth. Now, the first part of it was Pythagorean, which is named after a person. So see, the cool thing is, if you discover something or work on it and it gets attributed to you, they'll name it after you. Forever famous. Sweet. All right, so what on earth is this Pythagorean theorem? Okay, well, it's named after a mathematician named Pythagoras, and this particular mathematician lived a long time ago. So let's take a look at this. Ancient Greece in around 500 BC. So considering what today is, this is over 2,500 years ago, approximately, is when he was around. And so this particular law is attributed to his work, and it's all about right triangles. Now, we didn't talk that much about triangles this year because this was some work you've done in previous years in math. But in a right triangle, notice that I've got the 90-degree angle marked here. And we give special names to each of the sides of a right triangle. Okay, the two sides that make up the right angle are called legs. They may or may not be the same length. It just depends. So they could be the same, they might not be. It still can be a right triangle. And then this last side gets a special name because the last side is the one that's across from the 90. It's always the longest one in this case, and the special name we give it is called hypotenuse. Hypotenuse, okay? I don't even know where that comes from, so there's a good little extra credit project. You look it up, write it out, tell me where this word comes from and why it's referred to as the longest side in a right triangle, the side that's directly across from the 90. Perhaps you'll get some bonus points. Okay, well, as we learn about right triangles and things, there's a special relationship between the length of one of the legs, the length of the other leg. I should probably call this other leg because in this picture or diagram, it does not appear these are congruent. And then the hypotenuse. Okay, there's a special relationship with them, and we use them a lot when we get into even more mathematics called trigonometry. Oh, that's so much fun. All right, so what I want you to do is I want you to watch this little video that I found on YouTube for a moment because I think that it will help us tie into what I was having you do the other day with the squares and the triangles and how this relationship is important. Now, if you take a look at this, this is that first group of triangles or squares I had you use, where this was the 3x3, 9 squares. This was 4x4, 16 squares. And this last one on the hypotenuse side was the 25, because it was 5x5. Now, here's what they're doing. The 3x3, which was 3 squared, or 9, plus this one, which was 4x4, or 4 squared, 16, equals this 5x5 one, which was 25. 9 plus 16 is 25. So they'll do some cool graphics here to illustrate that's true. The power in this is that this isn't just true when my sides are 3, 4, and 5. It's actually true all the time. It's true all the time, which is pretty darn tootin' cool. So let's take a look at this one, okay? We can't just add each leg length together. 3 plus 4 does not equal 5. No, the relationship comes from this special property where you have to take one leg, let's say this one, which was 3, and this leg, which happened to be 4, and square them. Okay, well, we'll get to that in a second. The hypotenuse, which is 5, and then what we do is we say, oh my goodness, it turns out that this particular right triangle, I can take one leg and square that length. I can take the other leg, 4, square that length, and that's always going to equal the hypotenuse squared. Okay, and we just did that one. 9 and 16 do indeed make 25. Okay, 9 plus 16 is 25. It works. The beauty of this is that it works in every single right triangle. So we generalize that this way. We say, well, if I give a variable to one of the legs and they like to use the letter A, and then grab the other leg and call that variable B, and call the hypotenuse C, it turns out that leg squared, A squared, plus the other leg squared, B squared, equals the hypotenuse squared, which is C squared. So maybe you remember seeing this formula before. This is where it comes from and what it means. It only works for a right triangle. Okay, that's the only time it works. So let's put this into practice. Okay, here's a right triangle. It's lovely. I'm telling you that this side is 8. That's one of the legs. This side is 6. That's another one of the legs. Find the hypotenuse. Okay, well, my Pythagorean theorem says this. Leg squared plus other leg squared has to equal my hypotenuse squared, whatever that length is. Okay, or in other words, a squared plus b squared equals c squared. All right, now which one is a? Doesn't matter. Okay, just pick one of them. So if I say 8 squared plus 6 squared equals, I'm finding this, so that's my variable. All right, here's where it's important to have memorized these perfect squares. 64 and 36 is c squared. These two together give me 100. So now I'm telling you that some number c times itself is 100. In other words, c is going to be equal to the square root of 100, which is 10. Bingo. This particular one has a label of inches, so the hypotenuse is 10 inches. There you go. Let's try another one. Here's a nice triangle, 12 inches, 5 inches. Find the length of the hypotenuse. We always refer to the hypotenuse as c. 12 squared plus 5 squared equals c squared. If I think of this as a and b and c. Okay, 144 plus 25. That gives me 169. Woohoo! So that means c is the square root of 169, which means c is exactly 13 inches. There you go. Okay. Oh, look at this one. Here's a nice right triangle where my two legs are exactly the same. So when I go to plug it in to find my hypotenuse, I'm thinking, well, if I let this side be a, that's 4. And if I let this side be b, which is also 4, now I can find the hypotenuse. Okay, 16 plus 16 is c squared. That means that c squared is equal to 32. And I'm just going to get my calculator ready because I'm looking at this and I'm thinking, oh, boogers. You see, 32 isn't a perfect square. 36 is a perfect square. And as I'm looking at that and I'm thinking, well, let's see, it's not quite going to be equal to 6, so it's going to be 5 point something, but we'll have to figure out what it is. All right, so the square root of 32 is about 5, and usually they'll tell you what to round to, because c equals the square root of 32, which is approximately equal to 5.7. Let's say if I round to the 10th place. There you go. Okay, cool. What if, though, what if I give you one of the legs and the hypotenuse? Can you find the other side? Sure. As long as I've got 2 out of the 3 parts, we can figure out the other side. Remember that your equation says a squared plus b squared equals c squared. So here we go. A squared plus b squared equals c squared. This is c right here. Is this a or b, the 9? Doesn't matter. Okay, so if you want to call this a and call this b, that's fine and dandy. So a squared plus b squared equals c squared. All right, well, I simplify these to be 81 and 225. And then I'm thinking, well, I'm going to have to get a squared by itself. So I subtract 81 from each side. And oh, look at how beautiful that is. A squared is 144. So a is the square root of 144, which is exactly 12. So this side is exactly 12 inches. Sweet. All right, let's do one more. How about this one? You got one leg. I don't know this leg, and I know the hypotenuse for sure. So as I'm looking at this one, I'm going to say, well, if I call this one A and this one B, there's C. So I could say A squared plus 6 squared equals 14 squared. All right, let me get some numbers in here. Subtract the 36. And I get A squared is 160. Now, as I'm remembering what I know about perfect squares, I know that 160 isn't perfect. 169 would be exactly 13. So this should be close to 13, but not exactly equal to it. So A is going to be approximately equal to 12.6. And this is in inches again. Okay, about 12.6 inches. Sweet. Getting the hang of it now? Okay, so you'll be using your square root function a lot, and you'll be kind of working through determining what is the hypotenuse or what is one of the legs. That'll determine whether you add the squares together or have to do some subtraction, and then take a square root at the end. Okay? All right, so your assignment is going to be a worksheet today. So as soon as you get done, come on up and get the worksheet. And as always, may the force be with you.